If you listen to politicians in Washington, the global semiconductor war is entirely about artificial intelligence. The public discourse is almost entirely saturated with discussions about generative AI models, large language models, and the monumental computing power required to train them. The total global semiconductor market, which was valued at approximately $650 billion in 2024, according to comprehensive industry assessments, is frequently analyzed solely through this narrow lens of high-performance computing. The narrative focuses on a single, futuristic question: who can build the smallest, most advanced, most powerful microchip? This obsession centers on the bleeding edge of physics, pushing the boundaries of lithography to manufacture nodes at 3 nanometer, 2 nanometer, and even sub-2 nanometer architectures. These microscopic transistors, packed by the tens of billions onto a single piece of silicon, represent the pinnacle of human engineering. The United States is spending $52.7 billion through the CHIPS Act to make sure the answer to that question is America. This historic piece of legislation is designed to onshore the fabrication of these bleeding-edge components, heavily subsidizing companies to build state-of-the-art facilities on American soil to prevent supply chain disruptions in the ongoing AI arms race. But there is a massive, systemic blind spot in this strategy. While the media and lawmakers fixate on the race to 0 nanometers and the trillion-dollar market caps of the world's leading chip designers, a much quieter, vastly more pervasive crisis is unfolding at the foundational level of the technological stack. Advanced, cutting-edge chips only make up a fraction of the world's actual silicon diet. The vast majority of the microchips we use every single day are what the industry calls legacy chips. They are decades-old technology, they cost less than a cup of coffee, and they are not manufactured in a shiny new facility in Arizona. Because the US banned China from importing the machines required to make advanced AI chips, Beijing did something strategically terrifying. Facing a hard ceiling on their technological advancement, the Chinese government realized they could control the broader market by owning the base of the supply chain. They took all their billions in state funding and violently pivoted to dominating the legacy market. And they are using an economic weapon the capitalist West simply cannot match: infinite subsidies. To understand the threat, we first have to define the battlefield. What exactly is a legacy chip? In the semiconductor industry, a legacy or mature node generally refers to any chip built on a 28 nanometer process or older. To put that in perspective, the 28 nanometer lithography process was introduced into commercial production way back in 2011. It is essentially ancient history in the tech world. Beyond 28 nanometer, the legacy category also encompasses 40/45 nanometers, 65 nanometers, 90 nanometers, and even massive 0.25 micron architectures. You absolutely would not want a 28 nanometer chip powering your new smartphone or an NVIDIA AI server. Modern consumer electronics demand extreme power efficiency and processing density that only single-digit nanometer architectures can provide. But if you are building an electric vehicle, a smart refrigerator, an industrial robotic arm, or an artillery shell, you only want legacy chips. Why? Because older chips are physically larger, which makes them incredibly durable. The microscopic transistor gates of a 3 nanometer chip are highly susceptible to electromagnetic interference, extreme heat, and physical degradation. Legacy chips do not suffer from these vulnerabilities. They can survive the extreme thermal fluctuations of a car engine or the harsh radiation of low Earth orbit. They do not require the microscopic, fragile transistor architectures that define modern smartphones. Therefore, they are the blue-collar workers of the digital world. In 2024, legacy chips accounted for a staggering 76% of all global foundry production, and they are projected to still constitute 70% of the market by 2027. The legacy chip market itself is projected to reach over $300 billion globally, growing at a steady compound annual growth rate, CAGR, of roughly 4.4%. This matters right now because a single modern automobile requires between 1,000 and 3,000 of these semiconductor chips just to function. While a traditional internal combustion engine vehicle might use around 300 to 1,000 chips, the transition to modern electric vehicles, EVs, has triggered an unprecedented explosion in silicon demand. Engine control units, ECUs, Modern vehicles rely on sophisticated ECUs that utilize stepping motor drivers and three-phase motor drivers to manage propulsion. Driver assistance and safety, half-bridge pre-drivers, torque sensors, and angle sensors form the backbone of power steering and advanced collision avoidance systems. Power management. Electric and hybrid vehicles specifically require gate driver ICs for battery inverters, high-voltage motor pre-drivers, and incredibly precise battery current sensors to prevent catastrophic failures. Without them, the physical economy halts. If a manufacturer is missing just one 50-cent legacy chip that controls the power windows, the entire $60,000 vehicle cannot be sold. And right now, China is building the factories to produce them at a scale the world has never seen. We have actually seen this exact movie before. The historical precedent for what is happening in the semiconductor sector is thoroughly documented in the renewable energy market. In the early 2000s, Europe and the United States pioneered modern solar photovoltaic technology. Germany, through its aggressive renewable energy laws passed in the year 2000, essentially created the modern solar market. The German Erneuerbare Energiengesetz, EEG, established guaranteed grid feed-in tariffs, sparking a massive domestic boom in solar engineering and deployment. Western companies were poised to dominate the industry for a century. But then, the Chinese state identified solar technology as a strategic priority. Through the aggressive deployment of state-directed capital, Beijing heavily subsidized domestic solar factories. They provided free land, zero-interest loans, and massive tax rebates to local manufacturers. The result was a catastrophic market flood. By 2012, the global market was inundated with dirt-cheap Chinese solar panels, crashing prices far below the actual cost of production. Western companies, operating under the constraints of free market capitalism, simply could not compete with products being sold below cost. The carnage was swift. Suntech, once a darling of the Chinese solar sector, expanded relentlessly until the global pricing structure collapsed, forcing massive bankruptcies and restructurings across the entire industry. By 2017, SolarWorld, the pioneering flagship of the German solar industry, filed for insolvency. The company's CEO explicitly blamed illegal price dumping by Chinese competitors for their demise. Today, China controls over 90% of global solar cell production. They ran the playbook to absolute perfection. And today, they are running the exact same playbook with legacy microchips. To understand why America's dream of manufacturing affordable chips is difficult, we have to look at the brutal economics of chipmaking. In semiconductor manufacturing, the biggest cost is not labor, and it is not raw materials. It is depreciation. Building a modern wafer fabrication facility, known as a fab, requires a colossal capital expenditure. We are talking upward of $20 billion. Out of that, $4 to $6 billion goes just to constructing the physical cleanroom facility, managing 83,000 tons of steel reinforcement and 5,600 miles of cabling. The rest is spent on the highly specialized lithography and etching equipment required to pattern the wafers. Under standard accounting rules, this multi-billion-dollar investment must be paid down over the useful life of the equipment, which is usually 5 to 7 years. In corporate finance, this is heavily influenced by the Modified Accelerated Cost Recovery System, MACRS, which front-loads the deduction of these massive assets. The financial mechanics of this depreciation are actually quite straightforward. To find the depreciation expense for a given year, you simply take the initial cost of the factory equipment and multiply it by a mandated yearly depreciation rate. Because a modern fab requires tens of billions in upfront capital, this math frequently translates into multi-billion-dollar annual expenses on the corporate income statement. Therefore, every single microchip that rolls off the assembly line must carry a fraction of that factory's massive mortgage. We can analyze the baseline cost of producing a single wafer through a very simple equation. Cost per wafer equals the factory's total costs divided by the total volume of wafers produced. As long as those total costs, especially that astronomical depreciation mortgage, remain sky high, the minimum price to produce a wafer cannot drop below a strict floor. This fundamentally dictates the absolute cheapest price a chip can be sold for without the foundry taking a devastating financial loss. But what happens when the state steps in? If the Chinese government gives a company the land for free, hands them loans at 0% interest, and provides direct cash grants, their capital expenditure effectively drops to zero. Because the state absorbs the financial burden of the physical construction and the equipment procurement, the B variable in our depreciation equation is essentially erased. Through programs in tech hubs like Shenzhen, local governments generously subsidize the actual tape-out process of manufacturing. In Wuxi, factories have benefited from tailored preferential policies like the 5 free and 5 by half tax benefits. Furthermore, Beijing recently launched Big Fund Phase 3, a staggering $47 billion state-backed investment vehicle explicitly designed to accelerate the domestic chip ecosystem. Therefore, a Chinese foundry like Semiconductor Manufacturing International Corporation, or SMIC, does not have to price their chips to pay off a mortgage. They only have to price them to cover the variable costs, the electricity, the water, and the raw silicon. Because Chinese utilities are also heavily subsidized by the state, these variable costs are incredibly low. Furthermore, China currently accounts for nearly 80% of the total global estimated raw silicon production, producing roughly 7.4 million metric tons annually, giving them total leverage over material pricing. This allows Chinese foundries to manufacture and sell legacy chips at a price point that is physically impossible for Western companies to match. But here is the most ironic twist in this entire story. This aggressive Chinese expansion into legacy nodes was not purely an organic decision. It was directly accelerated by Western policy. In October 2022, the United States rolled out a sweeping series of export controls aimed at freezing China's artificial intelligence and advanced military capabilities by restricting access to advanced AI chips and specific deep ultraviolet (DUV) lithography tools. This followed earlier efforts beginning in 2019, when the US successfully pressured the Dutch government to block China from acquiring the extreme ultraviolet, or EUV, lithography machines necessary to build cutting-edge chips. These machines, exclusively manufactured by ASML in the Netherlands, cost hundreds of millions of dollars each and are the sole gatekeepers to sub-5 nanometer fabrication. This was supposed to cripple the Chinese tech sector. However, the policy had a massive, unintended consequence. Because Chinese foundries could no longer buy the tools to build the best chips, they took their hundreds of billions in state capital and redirected it entirely toward building the most chips. They doubled down on older deep ultraviolet lithography tools, which are not strictly restricted by sanctions, to master the mature nodes. The West inadvertently trapped itself. By blocking the ceiling of Chinese semiconductor advancement, Washington forced Beijing to aggressively expand outward across the foundation. This dynamic creates an impossible mathematical problem for the West. Companies like Texas Instruments in the US, NXP Semiconductors in the Netherlands, and global foundries operate in a strict capitalist system. They have to make a profit. They have to answer to shareholders and hit quarterly earnings expectations. To secure the domestic supply chain, these Western firms are currently spending billions. Texas Instruments is executing a massive $60 billion plan to build new 300mm wafer fabs in Texas and Utah, marking the largest investment in foundational semiconductor manufacturing in U.S. history. GlobalFoundries recently signed an agreement for $1.5 billion in CHIPS Act funding to modernize its sites in New York and Vermont. But building and running these factories in the West is exorbitantly expensive. Analytical models indicate that building a standard mature logic fab in the United States costs roughly 10% more in upfront capital and incurs up to 35% higher operating costs than a similar facility built in Asia. A recent analysis of TSMC's operations revealed a shocking disparity. The total production cost per wafer at their advanced facility in Taiwan was around $6,681. At their newly built facility in Arizona, the exact same wafer cost $16,123. Construction costs in the US are essentially double what they are in Asia, and it takes 38 months to build a facility from permitting to production compared to just 20 months in Taiwan or mainland China. Therefore, if a state-backed Chinese foundry sells a microcontroller for 10 cents, and it costs a US foundry 50 cents just to manufacture that exact same component, the capitalist system dictates an inevitable outcome. The US foundry will lose market share, margins will compress, and eventually, the Western company will simply stop making it. This is the definition of dumping, and the consequences are already materializing. Western chipmakers are already reporting intense pricing pressure originating from Chinese capacity expansion. In the silicon carbide wafer market, a foundational component for electric vehicles, Chinese fabs have slashed prices. A 6-inch wafer that cost $1,500 just 2 years ago is now being sold for $500 by Chinese suppliers. European executives are calling it a bloody knockout match. Now, there is a credible counter-argument to this fear. Some industry analysts suggest that this panic is overblown. They argue that China is simply engaging in import substitution. China is the world's factory. They currently import billions of dollars worth of chips to assemble into laptops and appliances. Therefore, skeptics argue, China is just building fabs to supply its own internal factories, not to conquer the globe. An industry study projected that by 2030, China's domestic capacity will cover around 90% of its own domestic demand. However, this assumption fundamentally underestimates the sheer scale of the expansion. China is adding more chip-making capacity than the rest of the world combined in 2024. According to industry analysis, they are projected to control 39% of all global legacy capacity by 2027. Currently, roughly 30% of global mature node front-end manufacturing capacity at the 20 to 45 nanometer and 50 to 180 nanometer nodes is already located within China. When domestic demand cannot absorb this massive subsidized supply, Chinese firms will do what they always do. They will export the excess to the rest of the world to survive. And once the Western factories are priced out of the market and close their doors, the West becomes entirely reliant on China for the chips that run their power grids, telecommunications networks, medical devices, and defense systems. How does the West stop this from happening? If Chinese legacy chips are artificially cheap due to state subsidies, the obvious political answer is tariffs. The United States and the European Union can theoretically utilize trade laws to slap a 100% tax on Chinese legacy chips, entirely neutralizing their price advantage. But semiconductors are fundamentally different from solar panels or steel. And this brings us to the embedded chip dilemma. Microchips are rarely imported in cardboard boxes. They are imported deep inside finished products. Consider a standard modern washing machine. It relies on a complex network of sensors and 8-bit or 32-bit microcontrollers to manage water temperature, drum speed, and the touch screen interface. These chips are almost universally legacy nodes. If the US imposes a 100% tariff on the raw silicon chip, the direct impact is minimal, because the vast majority of these chips are shipped from a Chinese fab directly to a Chinese or Vietnamese appliance assembly plant. To truly block cheap Chinese silicon, customs authorities would have to track the origin of every single microchip embedded within every single imported good. If a US manufacturer imports a fully assembled wiring harness for a Ford F-150 that contains 20 Chinese microcontrollers, does the US government tax the harness? Does it tax the entire $60,000 vehicle? A comprehensive survey published in December 2024 by the US Department of Commerce revealed the terrifying extent of this supply chain opacity. The report found that a staggering 44% of surveyed US companies were completely unable to determine whether their products contained any chips manufactured by Chinese foundries. Despite this massive blind spot, the data indicated that over 2/3 of all US products likely contain Chinese-made legacy chips. The usage is incredibly pervasive, yet incredibly shallow. PRC chips account for only about 2.8% of all chips by actual count. If tariffs are aggressively applied to downstream products to capture these embedded chips, the economic blowback would be severe. Economic models estimate that applying broad semiconductor tariffs would act as a massive, inflationary tax on the American consumer. The Information Technology and Innovation Foundation estimated that a 25% tariff would reduce the average American citizen's living standards by $122 in the first year alone, and cost the economy over $4,200 per individual over a decade. Blocking cheap Chinese silicon means raising the retail price of almost every manufactured good in the Western world. It is a massive tax on the consumer. Therefore, policymakers are staring down a brutal decision tree. In the best-case scenario, the West deploys highly targeted, smart sanctions that encourage manufacturers to use non-Chinese chips without triggering massive inflation. But given the absolute opacity of the global supply chain, this is practically impossible to enforce. In the base-case scenario, the US and EU apply broad tariffs, which succeed in protecting domestic foundries like Texas Instruments, but artificially raise the price of consumer electronics, cars, and medical devices for everyone. In the worst-case scenario, Western governments do nothing. Chinese foundries flood the market, Western legacy fabs go bankrupt, and the United States permanently surrenders control of the hardware that powers the modern world to its greatest geopolitical rival.